Hey guys, welcome to the Pre-Calculus Unit 3 preview. This unit is over solving triangles with vectors. Again, my name is Highland Turby. You can reach me at the email provided on your screen at any point. If you have any questions about planning your daily lessons or making it through a project or anything of the sort. Let's look at our agenda for this video. We are going to look at the goals for the unit, the inquiry and purpose, the essential understandings, some of the disciplinary connections that can happen during this unit, the unit project, some of the approaches to learning, the learning experiences and teaching strategies that go into that, our unit assessment, and of course walking through our daily lessons. Let's start with the unit plan itself. So the unit plan is made up of 3 sections, so we're going to start with our big goals for this unit. Because this is the first unit where scholars are introduced to their trigonometric functions, which they have not seen since geometry, our big focus is understanding right triangles and the unit circle. Sorry, I'm under the weather. So our students will be able to independently use their knowledge to understand the implications of right triangle trigonometry in the unit circle. So this unit is pretty heavy on the trigonometric ratios and how to use them in order to find reference angles, rotational angles, unit circles, rates of rotation, inverse trig functions, and how to calculate those within the unit circle. This is also a good opportunity for you guys to talk about maybe the hand trick or how you're going to teach these right triangle trig problems. So some factual questions you want to start with are like how to find the side length of a right triangle. Maybe review the Pythagorean theorem, which they've seen throughout high school, but sometimes our scholars forget, so I would definitely define the Pythagorean theorem and how it's tied to solving for right triangles. Finding an angle in a right triangle, angles of elevation, angles of depression, what is a vector? They all go together. Conceptually, we're looking for how triangles relate, what is the relationship between radians and degrees, and there's specifically an investigation in this unit that will be talked about at the round table coming up very shortly. We also need to know what magnitude and direction implies when we're talking about vectors. Some debatable questions that you want to bring into your classroom. What does evaluating a trig function at any angle mean in real life? How can the change of the size of the right triangle affect the sine or cosine ratios of its angles? And how does the unit circle solidify or enhance our understanding of a trig function? So there's some key questions to think about while you're planning your lessons and how you're going to tie them in to using them for checks for understanding or even just having a really good conversation in your class. Let's take a look at our essential understandings. The TEKs that we prioritized this time were determining values of trig ratios and angles, solving triangles in real-world problems, and adding vectors and multiplication. So those are our 2 priorities. Of course, we have other TEKs that we are going to cover, like converting angles to radians and degrees, finding rotations, reference angles, standard position, graphing trig functions towards the end, and of course, we're going to be looking at how to use all this to solve for right triangles. Make sure that you know what the outcomes are, like how students are going to learn and what they will be skilled out throughout this unit. Because this unit includes vectors, let's talk about what that entails. Now, in our study of vectors, we want to make sure that we're looking at adding and multiplying a vector by a scalar. We want to be able to find magnitude and direction. And we want to be how they are related to a real-world problem, specifically a trigonometric function. And then, of course, being able to apply it to a word problem that may not be involved with trig. But there is a direct connection between vectors and trigonometric functions. If you look at the components of vectors, they are directly tied. There's a list of vocabulary that the scholars should know throughout this unit. So some interdisciplinary connections that you could make, specifically with their physics classes. They go into depth of how vectors and forces of motion play a really big part with our study of vectors and our understanding. So I would have a conversation with your physics teacher and really know what they are expected to know in physics and what they're expected to know in your class and how they can relate to each other and help kids understand how to solve those real world problems. Also including interpreting the meaning of the solution, making connections to angular and rotational velocities using vectors, like the magnitude and direction of a force is moving in a certain way, or if you're rotating on a circular object, what kind of vectors play into that as well. So you can make connections in both classes, and I suggest that you just set aside time to meet with your physics teacher so that you know exactly what skills they need and what skills the scholars need in order to make your class successful. I would also make sure to push scholars to give you examples from physics in class to reinforce those transfer goals that we talked about. Stage 2, of course, is looking at the assessments for this unit. I have included a project which is angular thinking. This project is an excellent opportunity to have kids go outside and look at problems from the real world and be able to write a realistic trigonometric problem so that they can model it and solve it within the class. So scholars are going to be setting up a real world situation in order to change how they view the world around them and what implications the right triangle trigonometry has on the situation. I usually take my class outside. We look at the angles of the sun. We look at building angles. We look at what is happening in the neighborhood, whether it's like construction. If they can see and spot a triangular shaped problem, then they can apply what they know about trig and be able to solve it in the real world. There are 2 MYP rubrics. Your second option, of course, is to grade numerically on this presentation and how they present or write up their word problem based on their real world situation. The second assessment for this, of course, is the unit test. Let's go ahead and look at the unit test right now and see what's on it. So if you can see, they have to be able to look at standard positions of an angle and be able to calculate a trig function from another trig function, which can be complicated, but they need to understand how the ratios of the sides correspond to that specific trig function and what quadrant it lies in. You want to use all students take calculus in order to show which ones are positive and which ones are negative. Word problems are very heavy in this unit. They need to be able to read and label the word problem itself in order to calculate the appropriately missing side or angle. The sum of 2 vectors, we find out in this unit that if you add the first component to the first component, you get a new vector, and the second component with the second component. So it's like adding x's and adding y's to get your new vector. They have to be able to label their triangles and find the specific ratios for the given trig functions. They need to be able to identify the points that make up the initial and terminal side of a vector, so working backwards to what did you add together in order to get to this vector. Area of a sector, that should be a geometrical review question, but it's a good thing to revisit when you're looking at unit circles and talking about radian measures or degrees. Finding an angle between 2 given angles, so it's in a specific quadrant, whether it's positive or negative. Looking at the sum of the vectors, linear component form, like what does the I mean, what does the J, how are they worked together when you add 2 vectors together. That will be on the CA2. Make sure you guys review that. Evaluating a trig function by plugging in an angle. Looking at a physics problem with forces, like if you're given the magnitude, which is the pounds, and the angle, you can use the magnitude times cosine of the angle times, which is the x component, and then you can use the magnitude times cosine of the angle to get the y component. Make sure you review that. They also have specific right triangle problems where they have to draw the picture and be able to find out the angle of elevation versus the angle of depression and what side of the triangle they're solving for. Reference angles using the unit circle. There's a lot into this unit, but they're all tied together. They need to be able to draw 2 vectors together, and they also need to be able to use a point in order to find the terminal side of an angle and write their reference angles, reference triangles in order to find the ratio of their 6 trig functions. This test is challenging, but it's also a good way to understand where your kid's at. So let's go back to the unit plan. So for our stage 3, our approaches to learning are social because we want them to work well with others. Self-management, be able to regulate how they are involved in class, what state of mind they're at. You know, some of these topics can be very challenging for our scholars to work through, so it's important for us to make sure that they have the right mindset. Critical thinking, there are a lot of word problems involved in this unit, so they're going to need to analyze issues and come up with context and multiple representations. Some of the learning experiences for this. So while you're planning your daily lessons, I want you to be thinking about what you can do to involve more learning experiences for our scholars. So we want them, of course, to work with real-world applications. That's part of our transfer goal for this unit, and some of our big takeaways are specifically framed around real-world applications. So my suggestion is to engage in an investigation when we're converting from radians to degrees to see how they're connected to the unit circle, and I've planned that out in a specific AML for this unit. Whiteboard practice is essential as a daily practice. If you are trying to have scholars better understand how to solve for an angle, you can't just visit it once. They have to repeat and practice and practice. Small group instruction, especially around word problems, or even doing the project in small groups, can be effective in helping scholars to build their understanding. A gallery walk when solving for angles of an inverse trig. They can post problems around the room and share their ideas of how to solve it and then solve them together. Use a partner interview when you're talking about the vector components. Why do we list them as I and j? Why do we have the magnitude times cosine of the angle first? Make those connections with your scholars. Teaching strategy for the project, of course, if possible, go outside, see what they can find to create their situation and to solve a problem that they see in their neighborhood. It's challenging, but it can be done. I would also suggest, when we're talking about the unit circle, if you create fractional pieces of the unit circle, to lay out the parts and be able to help kids be able to count using radians. That is a very good strategy to use. Some differentiation for this unit. You could create a grasp for the project so that highlights their strengths. Have them show different ways of solving for a right triangle. There are multiple different trig functions, so they can do different paths when they're solving each problem. They don't always have to take the same path, but maybe have the scholars come up with their own paths. Make sure you look, when you're working in small groups, that you monitor the small groups and their progress, so you can give them specific feedback in the time frame of your class. I would use also manipulatives when you're talking about the unit circle, specifically those fractional pieces. So some formative assessments. You should be taking exit tickets daily to understand mastery and understanding of the content. Quizzes should be cumulative so that you can cover multiple concepts throughout a quiz to make sure that they're going to be successful on the unit exam. And of course the project as we move forward. Some real-world connections. I would take a look at these connections as we go through. The textbook has great word problems in there that are directly tied to some of these problems, so that you can talk about the pitch of a roof, photography of how the camera sets up and shoots at angles, laser beams, bearing and flight of an airplane is really great. Finding the height of a building, great connections to talk about during class. Pulleys, even rotational angles, momentum of a pendulum. In recent years, we've talked less and less about the pendulum movement because it's more related to Unit 4, but it can be done here because you can create that triangle relationship with its swinging back and forth. Construction, great way to connect to our daily lessons, and some of our kids have experience with that as well. Our sources for this unit come from Chapter 8, starting with right triangle trig and applications. Chapter 6 has the unit circle, and Chapter 9 has the vectors. So make sure you review those sections from the textbook, especially when you're planning your lessons. They have some good examples in there. So let's look at our daily lessons. We have day 1. You're looking at reviewing some area special right triangle rules. This is key for the ACT. I'd make sure that you pull some really challenging ACT questions around special right triangle rules or even Pythagorean theorem and tie that directly into your lesson. Day 2 is SOHCAHTOA, those applying trig ratios, how to identify what is sine, what is cosine. I would definitely use the acronym and help kids to understand that. You could also do a quiz on this day to really see how they're understanding Pythagorean theorem and special cases. Day 3, real world problem situations and trig ratios. I would introduce the class when talking about angles of elevation, angles of depression, and then I would have them work on their project of creating their own real world problem by going outside and looking at some of the pieces they can see and identifying those angles of elevation and depression, and even talking about maybe planes in the sky as well. Day 4, looking at converting radians to degrees. This is a great day to use my AML that I posted about Unit 3 so that they can see connections to the unit circle and how they're all tied together. Day 5 is linear and angular velocities. So how is velocities tied to rotations per minute, miles per hour? There's specifically questions in the CA too about angular and linear velocity. So if you need to go back and look at your CA to make sure that you are covering it appropriately, I would do so. Day 6, reference angles and 6 right triangles using a point. So basically we're going from more physical application problems into how does this apply to the unit circle and how can I use a coordinate plane to solve for those special ratios of trig functions. Day 7, exploring vectors. Make sure that you're talking about adding vectors, drawing vectors, components of vectors, magnitude, how trig is related to it, and of course forces as well. I would make sure you go back and look at the notes that I posted in previous years so that you can get a better idea of what's expected. And I'd also look at the unit test and the CA to see how vectors are also tested there. So the Unit 3 test should be 2 parts, multiple choice and constructed response, same fashion as the CA and any test going forward. Let's go ahead and look at the project handout. The project handout is built up of just 2 pages. They're going to write a physical word problem using academic vocabulary, and that directly ties into some of the literacy and discussion factors that we have in class. They need to be able to draw a picture of what they're talking about, like the triangle that it's made up of, or a physical picture of what they're looking at. And then on the back, they're going to do the solution. So they're going to solve their word problem with their partner, make sure they have a detailed description of how they solved it, and then a summary of their thoughts and progress throughout this lovely task. So basically our big takeaways for this unit are trig in all fashion with right triangles. This unit is not going outside of right triangles, so make sure that you're always referencing the right triangle and how to label the right triangle and the angles that are involved. I would also look at vectors and how it's tested on multiple levels. I would specifically look at making sure you know how to add vectors, draw vectors, and using the components of vectors. Connect with your physics teacher to make those direct connections. And also with the project, try to make it inclusive and make it fun for the scholars and go outside. I hope you have a great first part of your quarter 2. If you have any questions, feel free to reach out, and I'll look forward to seeing you. Thanks. Bye.